Hello students, good morning. So today's topic we are going to discuss is S block elements. Okay, so what are S block elements? So S block elements are present in the periodic table. Okay, so these are those in which the last electron will enter into the outermost S orbital. Okay, so here, the S orbital, the maximum number of electrons it can accommodate is how many? They can accommodate 2 electrons, right? So therefore, there are two groups which belongs to S block elements of the periodic table. So which is a group one? Group one is alkali metals. So group one, so there are basically two groups present in S block elements. So group one is alkali metals and group two is called as alkaline earth metals. So why it is called as alkali metals? Okay, so in alkali metals, the last electron, so it will enter into the ns orbital. Okay, ns1. So the last electron will enter into the s orbital, and the number of electron present will be 1. So the outermost electron, it will accommodate only 1 electron. So it is having ns1 configuration. So the electronic configuration of alkali metals is ns1. And for alkaline earth metals, the electronic configuration is ns2. Okay, so which are the metals present in this group 1? So group 1 alkali metals, they are lithium, sodium, potassium, rubidium, cesium, francium. Okay, So these are the elements which are present in group 1. So which are the elements which are present in group 2? Okay, so they are beryllium, magnesium, calcium, then strontium, barium, and cesium. Okay, so these are the elements which are present in your group 2. Okay, so these are the elements which are present in group 2. So alkali metals and alkaline earth metals together, they comprise of S block elements. So the general electronic configuration is NS1 for alkali metals and NS2 for alkaline earth metals. So all the alkali metals, as they have one electron, okay, so the valence electron is one outside the noble gas configuration, so they are loosely held. So the electrons are loosely held in the outermost s orbital, and thus it makes this both group 1 and group 2 electropositive in nature. So these are all metals, group 1 and group 2, these are metals. Okay, so as the electrons are loosely held in the outermost shell, so it can easily give the electrons. Okay, it can easily give the electrons so that it completes it. So it will have a stable octet. So they readily lose electron, and thus they form what? It will form M plus. M plus ions means what? Plus indicates what? Plus indicate that there is a loss of electron. Okay, that is they are giving electrons. So that is M plus ions. So they can readily give electrons or they can readily lose electrons. So then in case of, this is with respect to alkali metals, it has only one one electron, so it can readily give one electron. And in case of alkaline earth metal, how many electrons are there in the outermost shell? There are two. Okay, there are two electrons present in the outermost shell, so they can easily give the two electrons in their from their valence shell orbitals. Okay, so those what type of ions it forms? It forms M plus 2. It forms M plus 2. Okay. So next we'll see, this is atomic radii. So we'll see what atomic radii. So you know what is atomic radii. We had discussed some of these properties in brief in classification of elements and periodicity properties. Okay. So what is atomic radii? It is the half the distance between the internuclear distance between the two atoms. Okay. So atomic radii. So atomic radii, how it varies across the period and down the group. So this is for your group 1. So you can see lithium, sodium, potassium, rubidium. Okay, these are the elements present in group 1. So what you can see as you go down the group, okay, as you go down the group, what will happen to the atomic size? Atomic size will increase. What is the reason for increase in atomic size? Because as you go down the group, the atomic number increases. Okay, as atomic number increases, what will happen? The number of shells also increases. So as you go down the group, the number of shells increases. So as a result, as you go down, the atomic size also increases. So lithium will have the least size as you go down. Okay, so rubidium will be having a higher atomic size. What is the reason? As you go down this group, the number of shells go on increasing. Okay, then across the this what across the period, when we are talking about across the period, so group 2, okay, group 1 is here, so group 2 will be beside the group 1. So group 2, okay, so now this group 2 are what? It is beryllium. Okay, beryllium, magnesium, calcium, strontium. So what is happening across the period? Now lithium comes this side. Okay, then comes beryllium. So it is moving across the period. So when you're talking about across the period, when you're talking about atomic size, so what happens to atomic size? Atomic size go on decreasing. Why? What is the reason for atomic size decreasing? Atomic size across the period? The reason is that when you go across the period, there is addition of electron. Okay, addition of single electron in each in the same shell. Okay, in the same shell only there is what? There is addition of extra electron. So what will happen when you're adding extra electron across the period? the nucleus, okay, nucleus will have what? It will have a positive charge. So what it will do? It will tend to pull the outermost electron towards itself, okay. It will tend to pull the outermost electron towards itself. So as a result, there will be increase in effective nuclear charge. So it will tend to pull the electron towards itself. So there is an increase in effective nuclear charge. So what is the reason? So as a result, what will happen? It will pull the electron towards itself. So the size go on decreasing. So across the period, the atomic size go on decreasing. So what is, remember, when you go down the group, okay, when you go down the group, the atomic size increases. Reason is number of shells go on increasing. So as you go down, the number of shells increases. Then group 2, as it is across the period, what will happen to the size? Atomic size decreases. The reason is there is increase in effective nuclear charge. So this is the reason for atomic radius. Okay. Next is ionization enthalpy, okay, or ionization energy. What do you mean by ionization enthalpy or ionization energy? It is the minimum amount of energy which is required to remove the electron, okay, to remove the last electron, from its isolated gaseous atom, okay, to remove the last electron from its isolated gaseous atom. So when we are talking about the group 1 and group 2, right, we are studying about S block elements. So we have to consider the ionization enthalpy for group 1 and group 2. So when you're talking about group 1, so group 1 elements, what will happen to the ionization enthalpy? So ionization enthalpy of alkali metals are low, okay. Why? Because they are low as it is going down, okay. How it varies, it when you go, as you go down the group, the ionization enthalpy decreases. So what is the reason why the ionization enthalpy decreases down the group? Because there is increase in the size, okay, because there is increase in the size. So as what is ionization enthalpy? So the amount of energy which is required to remove. So when you are removing this electron, okay, last electron from lithium, so what it will do? It will tend to, the energy required will be more. But as you go down, okay, the number of shells are more. So the effective nuclear charge will go on decreasing. So you can easily remove the last electron, okay, you can easily remove the last electron. So as you go down the group, what will happen to ionization enthalpy? It goes on decreasing. The reason is there is decrease in the effective nuclear charge. Okay. Then for group 2, when we are talking about group 2, the ionization enthalpy of alkaline earth metals are higher. So as compared to group 1, alkaline for alkaline earth metals, the ionization enthalpy is higher. What is the reason? Because as you go across the period, okay, as you go across the period, what will happen? Ionization enthalpy will increase. Why? Because due to the small size, so the effective nuclear charge will be more, right? So it will tend to pull the electron towards itself. So there is the addition of electron in the same shell. So as a result, there is increase in the, as it is a small size, as well as there is increase in the effective nuclear charge. So the ionization enthalpy or the energy required to remove this electron will be more. So down the group, what will happen? In down the group, when you are studying for, what will happen to ionization enthalpy? Ionization enthalpy will decrease. And when you are so when you are comparing group 1 and group 2, ionization enthalpy will be more. Just here. So first ionization enthalpy of group 1 elements are lower. Okay. Then first ionization enthalpy of group 2. Okay. Then with respect to second ionization enthalpy of group 1 elements are greater than the second ionization enthalpy of group 2. So this is the reason for ionization enthalpy. Next, we'll see the hydration enthalpy. Okay, this is about oxidation state. Before going to hydration, we'll see about hydration enthalpy. Okay, so hydration enthalpy of group 1, when you are comparing the hydration enthalpy of group 1, it decreases with the increase in ionic size. So you know how the ionic size or how the ionic radius varies down the period. Okay, down the group. So how it varies? So as you go down the group, the ionic size go on increasing, right? So for when you're comparing the hydration enthalpy, okay, hydration enthalpy when you're comparing. So what is hydration enthalpy? It is the energy released when 1 mole of ions undergo hydration. So it is the energy released when 1 mole of ions undergo hydration. So when you're comparing the hydration enthalpy, so as you go down the group, what will happen to hydration enthalpy? It goes on decreases. Okay, so remember hydration enthalpy decreases with increase in ionic size. So with respect to lithium, when you're comparing the lithium, so when you're comparing the lithium here, okay, so what will happen to lithium? So lithium, as it is having a smaller size, okay, lithium will have small size. So what will happen to hydration enthalpy? Hydration enthalpy will be more. So as you go down the group, hydration enthalpy keeps on decreasing. So lithium hydration enthalpy will be more as compared to sodium, then as compared to potassium, rubidium, cesium. Okay. So this is, so lithium will have the highest degree of hydration. So the reason for this, that as hydration enthalpy of lithium is greater or degree of hydration is more, so most of the salts of lithium are hydrated. Okay, they are hydrated. So when you compare the hydration enthalpy of group 2, so this is also same. So as you go down the group, what will happen to the size of the elements? Beryllium, magnesium, calcium, as you go down, the atomic radii keeps on increasing. So as a result, the hydration enthalpy, it will decrease. Okay, so it will decrease. So the hydration enthalpy for beryllium will be more as compared to that of magnesium, calcium, and so on. So this is with respect to your hydration enthalpy. So next we'll see the oxidation state. So group one are what? They are alkali metals. So group 1 elements, in that the outermost electron, how many electrons are there? 1 electron is there. So it can readily give or it can readily lose 1 electron. So alkali metals, they can form which state? When it is losing 1 electron. Okay, so it can easily give 1 electron, so it forms +1 state, right? So sodium +1, potassium +1, okay, like this it forms. So it can readily give 1 electron. So it can readily give 1 electron. So the oxidation state of alkali metals is +1. In alkaline earth metals, the number of electrons, the outermost electronic shell, it consists of how many? It gives 2 electron. It can give 2 electron to be stable, okay, to complete or to have its octet. So it can readily give 2 electrons. So thus it will have +2 state. So it will have what? It will have +2 state. So reducing property. So the reducing character of any metal. So the reducing property of any metal is best measured in its electrode potential. Okay. So lithium is a good reducing agent. So it is lithium is a good reducing agent, hence it is the strongest, it is said to be a strongest reducing agent. Okay, so and as compared to alkali metals, alkaline earth metals are a bit weaker. So they are a bit weaker reducing agent compared to the alkali metals. So what is the role of reducing agent? Reducing agent, it reduces other and itself undergoes oxidation. Okay, so lithium is the best reducing agent. It reduces other and itself undergoes oxidation. So when you're comparing alkali and alkaline earth metals, alkali metals are an excellent reducing agent as compared to that of alkaline earth metals. Okay, so this is the series of reducing agent. Okay, so this is the reducing character of alkali metal. Sodium is less than potassium, is less than rubidium, is less than cesium, is less than lithium. So lithium is the most excellent reducing agent. So next we'll see the metallic and non-metallic character. Okay, metallic character. Now I said what group 1, where group 1 are present? Group 1 are present in the periodic table. Where it is present? It is present to the left side of the periodic table. Okay, so metals are present here, right? So metals are present to the left side of the periodic table. So what will happen to the metallic character as you go? So these are all metals. So as you go down the group, okay, the metallic character goes on increasing, or the electropositive nature, okay, it keeps on increasing. And as you go across the period, what will happen to metallic character? It will decrease. Why? To your right side, what are present? Non-metals are present, right? So as you go across the period, what will happen to metallic character? It decreases, okay? It decreases across the period and increases down the group. So metallic character, so alkali metals, so most it will have a metallic character. So it will show, most of the metals will show metallic character. Alkaline earth metals, so it is just across the period, right? It is just side to the alkali metal, so you're moving across the period. So what will happen? Little the metallic character is been less, okay? The metallic character here is less as compared to that of the alkali metal. So in alkaline earth metals, the metallic character is less because you're moving across the period. Then electropositive character. So what is the electropositive character? What do you mean by electropositive character? That is the metals which have the great tendency. So these metals have what? It has a great tendency to lose electron. So if it lose one electron, it will form what? It will form M plus ions. Okay. So these metals are highly electropositive in nature. So as I said, as it has a greater tendency to lose electrons, so they are highly electropositive in nature. So the metallic character increases down the group and decreases across the period. So remember this. So as you are moving across the period, to your right side, what will happen to metallic character? It decreases. Okay. So this is with respect to your metallic character. And if you are talking about non-metallic character, it will be vice versa. Okay. Metallic character down the group, what will happen to non-metallic character? It will decrease. Okay. Down the group, the metallic character will decrease, and across the periods, what will happen to non-metallic character? It will increase. Okay. So this is with respect to the metallic and non-metallic properties. Next is we'll see the melting point and boiling point. So when we are going to compare it with alkali and alkaline earth metals. So melting point and boiling point. So when you have metal and non-metals, okay, when you combine metals and non-metals, it will form what type of bond? It will form ionic bond. When you form, the atoms, okay, the atoms or elements are non-metals, okay, both are non-metals, then it will have a covalent bond. And when you have metal, so when metals are there, it will form what type of bond? It will be a metallic bond. So what will happen to boiling point and melting point? Okay, so it will decrease. So it will have a very low, and it decreases with the increase in the atomic number. Okay, so as in alkali metals, they have large size. So as you go down the group, what will happen to melting point? It will decrease. What is the reason? Because as you go down the group, what will happen to the size? It will be the size will what will happen to the size? The size will increase. Okay, the size of that atom, as you go down the group, it will increase. So as a result, what will happen to the metal bond, that is metallic bond? There will be less intermetallic bonds. Okay, so the intermetallic bonds, that is the bond between the metal, it will be bit weak. So as you go down the group, as the size is more, what will happen to the bond between the metal, it will be weak. So those the melting point, it decreases when you move from this, as you move down the group. So as you go, so what will happen to the this? So melting point. So as you go down, so francium is present at the bottom. So it is a liquid in state. So group 2, as compared to group 1, that is alkali metals, group 2 elements will have higher melting point and boiling point. Because why? As you go across the period, what will happen to the atomic size? Atomic size will be decreasing, right? As compared to alkali metal, what will happen to alkaline earth metal? The size will be little small. So the alkaline earth metal, the size will be small. So as compared to alkali metals, alkaline earth metals, they have higher melting point and boiling point than group 1. Next is density. What is density? Density is nothing but your mass per volume. So alkali metals, they have low density. Okay. So lithium is the example. So what will happen to the density as you go? So lithium is having a very low density. So lithium, what is the atomic mass? Atomic mass is small. So as you go from this, as you go down the group, what will happen to the atomic size? It increases. So mass is directly proportional to your density. Okay. So as you go down the group, what will happen to the density of the elements? It increases. Okay. So it increases from top to bottom as the atomic mass increases. So lithium is the first element of the alkali metal, so it will have a low density. So it is the lightest element. So as compared to alkali metals, alkaline earth metals are denser than alkali metals. So as you go down the group, what will happen? The atomic mass increases, which more than compensates the bigger atomic size. Therefore, density also increases. So as you go down, what will happen to atomic size? Atomic size increases. So as a result, what will happen to density? Density also increases. So when you are seeing a bit of this is observed that potassium, however, is lighter than sodium, but due to the abnormal increase in its atomic size because of presence of penultimate d orbitals. So because of the penultimate d orbitals, there is a bit difference in the atomic size you can see across the trend. Okay. So calcium is also less than magnesium because of the presence of penultimate d orbitals. So the size is bit, so you can see when you're comparing the this units, okay, when you're comparing the numbers, the atomic sizes or melting and boiling point, that time you can see a bit calcium is less. Okay, after magnesium, calcium comes, but because of the presence of this d orbitals, there is a little variation. Okay. So next we'll see flame coloration. Okay, we'll see the flame coloration. So alkali metals. So these are the different flames which are shown by the different metals. So here, so lithium. Okay, lithium shows crimson red. So what is a flame? You do this test. Okay, flame test in your qualitative analysis, right? When you are estimating the salt analysis. So what is flame test? What you are doing? You are taking the salt. Okay, you are taking the salt. You are adding concentrated HCl. You are making a fine paste, and you are supplying some energy. What you are doing? You are burning it in the flame, right? You are heating it in the flame. So what you are doing? You are supplying some energy. Okay, you are supplying the heat. What is happening? The electrons will get excited. Okay, the electrons will get excited, and when it comes back from the higher state to lower state, what will happen? It will emit the radiation. So these are characteristic color shown by the different elements. So lithium, it shows crimson red. Then your sodium shows golden yellow. So this is the golden yellow which is shown by sodium. Then potassium shows pale violet. Okay, this is the color being shown by potassium. Then rubidium shows purple color. It shows purple color. Then cesium shows sky blue. Okay, it is a bit of violet color is shown by this alkali metal. So these are the flames shown by different elements of the alkali metals. So francium being radioactive does not give any flame coloration. Okay, francium, as it is a radioactive element, it does not give any flame coloration. So now we'll see with respect to alkaline earth metals. Alkaline earth metals, calcium. Okay, calcium shows a brick red. Your strontium shows crimson red. Then barium shows apple green. Okay, barium shows apple green. Then radium shows crimson. Okay, so these are, so beryllium and magnesium, because of their high ionization enthalpies, do not impart any characteristic color to the Bunsen burner. So because of high ionization enthalpy, okay, it does not show any coloration. So based on this, we'll solve some questions. Okay, so now here you can see the increasing order of ionic character. So increasing order of ionic character, the increasing order of ionic character of CSF, Ni, NaBr and KCl. So you have to tell the what is the increasing order of this ionic character. So what will happen to ionic character? So ionic character is different. Okay, between, so here one positive and one negative element is there. So these are all halogens. Halogens. Okay, which are the halogen, different halogen present. So fluorine, chlorine, bromine, and iodine. So if you write the ionic, so what will happen to ionic character? Ionic character will increase. Okay, ionic character will increase with the increase in difference between the electronegativity. So between this bonded atoms. So what will happen? Ionic character, it increases with the increase in electronegativity. So the order of electropositivity. So lithium, what if you're comparing the order of positivity of this cations? So lithium is less than sodium, which is less than potassium, which is less than cesium. Okay. So, and order of negativity. So this is the order of positivity. This is the order of negativity. Okay. We'll write the order of negativity. So iodine is less as compared to bromine, as compared to Cl, as compared to F. Okay. So here, which will have the highest this, it will be, which will, what is the correct answer? So if I give this order, when you're comparing, so ionic character, it increases with the increase in difference between the electronegativity between the bonded atoms. So it can be shown more in what? You have to tell the not C. C, it is what? It is the lithium iodide will be less. It is B. Okay, the ionic character, you have to tell the increasing order. So it is the B. Okay, so you have to tell the increasing order of ionic character. So here what will happen? So lithium is less as compared to this. So it will have, so this is the next. The solubility of alkali metal hydroxide follows the order. Okay. So when you're, what will happen to the size as you go down the group? The size will, it will, what will happen to the size? Size will increase. Okay. So lithium will have least size as compared to that of the sodium, potassium, rubidium. So if you write the trend, okay, for increase, it will be lithium will be less as compared to sodium, as compared to potassium, then rubidium, and then your cesium. So when you're comparing this, okay, now you want to see the solubility of alkali metal hydroxide. Alkali metal hydroxide. So metal hydroxide, how it is formed? So it is the bond dissociation energy you have to see. Now the bond dissociation energy is what? Dissociation energy, bond dissociation energy is nothing but the energy which is required to break, okay, the break the two atoms or elements. Okay. So here the bond dissociation energy of this hydroxide will decrease in the order of LiH, okay, is less than NaOH, which is less than KOH, rubidium. So it will from lithium. So because as you go down the group, what will happen? There will be increase. So you can easily break this lithium hydroxide as compared to that of cesium hydroxide. So the solubility of alkali will be what? The answer is A. Okay. Because of bond dissociation enthalpy. So lithium hydroxide, it can be easily what? It can be easily broken as compared to that of the sodium, potassium, rubidium, and cesium. So based on the bond dissociation enthalpy, you are considering this based on the bond dissociation enthalpy. So as you go down the group, what will happen? The size will be more. So as the size will be more, breaking of the two atoms will be difficult. So lithium, so this will be, it follows this order. So A is the correct answer. In view of their low ionization enthalpy energies, the alkali metals are. Yes, what is the answer? In view of their low ionization enthalpy. So because alkali metals are low, they are having low ionization enthalpy, they are good. They are strong what? They are strong reducing agent. Yes, correct answer is B. Strong reducing agent, right? Alkali metals, lithium is having a low ionization energy. So because of this condition, it is strong reducing agent. Among the alkali metals, cesium is the most reactive metal. What is the reason why cesium is most reactive? Why it is said to be most reactive? See the options. options and answer. Yes. Why cesium is most reactive? The outermost electron, so the option is D. Okay, the outermost electron is more loosely bound than the outermost electron of the other alkali metal. As you know, cesium, as you go down the group, what will happen? The number of shell will increase. So the nucleus, it will not have so much attraction towards the outermost electron. So as a result, the outermost electron is very loosely held. So cesium is highly reactive in nature. So this is the reason. Which of the following has maximum ionization energy? Yes. Which one of this will have maximum ionization energy? What is the answer? Magnesium, beryllium, magnesium, calcium, strontium. Yes. See, when you're comparing magnesium and calcium, okay, here only one electron is removed. But when you're removing the second electron, okay, when you're removing the second electron, the energy required will be more. So after removal of one electron, what will happen to the effective nuclear charge? So the answer is D. Okay. So when you're removing one electron, what will happen to the effective nuclear charge? Effective nuclear charge will increase. So whatever the outermost electrons are there, okay, when you remove one electron, so effective nuclear charge will increase. So as a result, what will happen? Whatever the remaining outermost electrons are there, they will be held more tightly by the this nucleus. Okay. So because of this, the reason is that it will have high ionization enthalpy. So the answer is D. Answer is D. Okay, when you're comparing, so this is with respect to only one electron. But with calcium and magnesium, magnesium will have more. Why? Because when you remove one electron, the nucleus will they will hold the outermost electron more tightly. So as a result, what will happen when you try to remove the second electron? The nucleus, the energy required will be more. It will have it wants what? Maximum ionization energy. So magnesium. So D is the correct answer. Okay. Density is the highest for. How do density vary? Density, as you go down the group, what will happen to the density? What will happen to the density as you go down the group? As you go down the group, what will happen to the density? Density will what will happen to density as you go down the group? Density will increase because of increase in atomic size. So barium. So correct answer is barium. Okay. D is the correct answer. Barium. Barium is the correct answer. Which of the following is used as scavenger in metallurgy? What do you mean by scavenger? Scavenger is nothing but it is a substance which is used to remove the impurities. Okay, it is used to remove any kind of impurities, whatever the traces of impurities is formed in the metal. For example, some water molecule, okay, or some other elements which are present. So that is nothing but scavenger. This is scavenger. So what is scavenger? It is calcium. Okay, example correct is calcium. C is the correct answer. So calcium is used as a scavenger in metallurgy. It is used to remove the impurities. So in comparison to alkaline earth metals are. Yes, in comparison to alkaline earth metals are less reactive, less reducing, less basic, all the three. What is the correct answer? It is all the three. Okay. So alkaline earth metals are less reactive, they are less reducing property, and they are less basic. So this is the reason. How does the ionization energy of first group elements vary? How does they vary down the group? How does the ionization energy of the first group elements vary? Yes, what is the option? Ionization energy, it will, yes, it will decrease down the group. So it will decrease down the group. Why? Because of increase in atomic size or number of shells. Okay, as the number of shell increases, the distance between or the effective nuclear charge will reduce. Okay, so this is the reason. Next, which compound is highest covalent? Which compound is highest covalent? Which is the compound which is highest covalent? The answer is D. Okay, what is the reason? D, since iodine is least electronegative, okay, this lithium iodide will have a least electronegative difference. So that is the reason it is covalent. Okay, smaller, Fajans rule, right? Small is the size of the cation, larger should be the anion, right? Larger should be the anion. So according to Fajans rule. So which is having the highest? Lithium is least, and iodine will be having the most larger the size. So and lithium will be having a size is very small. So lithium. So according to Fajan's rule, lithium iodide. So it is highest covalent. Okay. Smaller the size of the cation, larger the anion, greater its covalent character. So this is Fajan's rule. When sodium is treated with sufficient oxygen or air, what is the product obtained? Yes, what is the product obtained? When sodium, it reacts with oxygen, what is obtained? It is Na2O2. Okay, B. B is the correct answer. Na2O2. So this is the correct answer. So this is of the following compounds, which is most stable? So which is most stable? So the most stable element is A. So right, what is the reason? Okay, so which is the most stable compound? It is LiF. Okay, lithium fluoride. So what is the reason? Greater the electronegativity. Okay, greater the electronegativity. Fluorine is a highly electronegative element. Or smaller the size of the element, stronger is the bond formed. Okay, so greater the electronegative character of this element. So if fluorine is highly electronegative and lithium is very small in size, what will happen? The stronger is the bond form. So lithium fluoride is most stable as compared to that of lithium chloride, then lithium bromide and lithium iodide. So electronegativity, so it is more stable. So more the electronegative character of the electronegative atom, small the size of the cation. Okay, stronger is the bond form. So this is most stable compound. So globulars salt is. Okay, what is the correct option? It is Na2SO4, sodium sulfate dot, okay, decahydrate, sulfate. So it is a decahydrate of sodium sulfate. So globular salt is nothing but decahydrate. 10 is what? Decahydrate of sodium sulfate. So this is the correct answer. The appearance of color in solid alkali metal halides is generally due to. Yes, what is the reason for the appearance of color? It is due to the what? It is due to the F centers. Okay, the answer is F center. So what do you mean by F center? What do you mean by F center? It is a anionic vacancy. Okay, it is the anionic vacancy which is created by the okay, in which there are unpaired electrons will occupy. So it is F center. So it is D is the option, F centers. So alkali metal halides have anionic sites which are occupied by the unpaired electrons. So F centers, they impart color. Okay, they impart color. So appearance of color in solid alkali metal halides. So in metal halides, the color is due to generally due to F centers. F centers are nothing but they are the anionic vacancies in which unpaired electrons will occupy. Okay, it will occupy the sites. Photoelectric effect is maximum is, yes. What do you mean by photoelectric effect? What do you mean by photoelectric effect? When a beam of light, okay, when a beam of light is incident on a metal surface, okay, so with no time lag, okay, with no time lag, there will be ejection of electrons from that metal surface. So this is nothing but photoelectric effect. So photoelectric effect is mostly seen in what? It is seen in cesium. A is the option. Okay, cesium. Photoelectric effect is observed in cesium because what will happen? Emission of electrons is maximum because the ionization enthalpy is less, right? What is the reason? See, ejection of electrons will be more. Why the ejection of electrons will be more? Because cesium, as you go down, what will happen to ionization enthalpy? And then ionization enthalpy will be less, right? It will decrease. So as a result, the effective nuclear charge will be less. So it can eject more electrons. So when more electrons can be ejected, when you have loosely held electrons. So here cesium. So photoelectric effect is maximum in cesium. So this is the right answer. Next, diagonal relationship and chemical properties. Okay, what do you mean by diagonal relationship? So diagonal relationship is said to be exist between certain pairs. So diagonally. So when you are comparing the periodic table, the elements which are held diagonally, okay, these are diagonally held. These are diagonally held or they are diagonally adjacent elements. So these are said to be having certain similar properties. Okay, so the relationship, so the diagonal relationship is said to be existing between certain pairs which are held diagonally adjacent elements in second and third periods of the periodic table. So these are seen in second and third periods of the periodic table. So these lithium and magnesium is said to be having a similar diagonal relationship. Then beryllium and aluminum is said to be having a diagonal relationship. So it is diagonally. Okay, the elements which are placed diagonally, they are said to have similar relationship or they have certain similar properties. Now, what is the similarities between lithium and magnesium? So when you are comparing the similarities, that is a diagonal relationship between these. So these are certain, you can see similarities. So why, what is the reason for the similarities? Because there is similar, this what ionic size is similar and charge to radius ratio. Okay, that is polarizity ratio. So because of ionic size and charge to radius ratio, they are showing, that is lithium, magnesium and beryllium, aluminum are showing the similar properties. So atomic radii, you can see lithium, it is what? It is 152 picometer. Magnesium 160 picometer. So it is almost same. Lithium plus, okay, lithium ion 76 picometer, it is ionic radii, and Mg plus, okay, Mg plus 2, it is 72 picometer. Polarizing power of lithium ion is 1.7 and magnesium ion is 3.9. Electronegativity difference of lithium is 1 and magnesium is 1.20. So these are having certain similar properties. What is the reason? Due to their small ionic sizes and that is due to their similar ionic sizes and charge to radius ratio. So they are showing diagonal relationship. Next, the chemistry of lithium is very similar to that of magnesium, even though they are placed in different groups. Why? What is the reason? What is the reason? Their ratio. their ratio of their charge to size is nearly the same. Okay. So next we'll see the chemical properties. Okay. We'll see the chemical properties of alkali metals. So when it reacts with water, water is nothing but your moisture. So when metal reacts with water, it forms metal hydroxide plus hydrogen is liberated. Lithium, when it reacts with water, what it forms? Lithium hydride. Okay. Lithium hydroxide plus H2. Hydrogen gas is liberated. Sodium, when reacts with water, it forms sodium hydroxide and H2 is liberated. H2 gas is liberated. So as you go down, what will happen to the reactivity? Reactivity will increase. So the less reactive is lithium. So lithium reacts it is less reactive, and as you go down, cesium will be most reactive. So lithium hydroxide is a weak base as compared to the other hydroxides. So other hydroxide are highly basic in nature, while lithium hydroxide is a bit weak base. Okay. Then when we are comparing the reaction with air or oxygen, so metals, when they react with lithium, it forms metal oxides. Okay, it is Li2O. You can see the example. So when lithium reacts with oxygen, it forms a metal oxide. So higher, so as you go down, so that is sodium, it forms, as you go down the group, what will happen? It will form oxides of greater this. Okay, so when you react your sodium, when sodium reacts with oxygen, it forms metal peroxide. Okay, there is OO linkage. You can see here OO linkage is present. So only sodium. So higher metals, they form higher oxides. Okay, so here when you are comparing your when you are reacting your oxygen with your lithium, okay, so it forms simple metal oxide. Then sodium, when it is reacting with oxygen, it forms metal peroxide, that is sodium peroxide. So you can see this linkage. This is a peroxide linkage. Okay. Then higher metals like potassium, rubidium, and cesium, it forms what? Superoxide. Okay, it forms superoxide. So it is example is given of potassium. So potassium, when it reacts with oxygen O2, it gives you KO2. Okay, potassium. So it forms a superoxide. So higher elements, it forms superoxides are of higher category. Okay. So you can see here. So first is the lithium. So lithium, it forms the oxide ion. So peroxide, so sodium, as you go down the group, okay, as you go down the group, the oxygen, so small cation will be stabilized by the small anion. So here only the lithium forms the monoxide, while the others, they form oxides of higher versions. Okay. Sodium, it forms peroxide, potassium, rubidium, and cesium, it forms superoxides. So only lithium, it forms monooxides. So what do you mean by anomalous properties? Okay, what do you mean by anomalous properties? Anomalous properties is shown by the first element. So for in group one, okay, in group one, which is the element which shows anomalous properties, it is lithium. Okay, it is lithium. So it is the lithium. So so lithium, and in the case of this what group 2, it is beryllium. So beryllium and lithium, they will show some they are bit different. Anomalous properties means what? They will show some different properties as compared to the other elements of that particular group. Now why it shows different properties or some anomalous behavior? It is due to this following reason. It is because of the small size. Okay, it is due to the small size, high ionization enthalpy. Okay, as you know, the first element is having high ionization enthalpy. Then it is due to high electronegativity, the value, high electronegativity value, and high polarizing power. What do you mean by polarizing power? Charge to radius ratio. Okay, so this is the reasons why the first element, that is lithium, is showing different behavior or it is showing anomalous behavior as compared to the other elements. And in group 2, beryllium is showing anomalous behavior as compared to the other elements. So it is due to these reasons. Okay, so these are the reasons. So which one of the alkali metals forms only the normal oxide? Yes, we had discussed this. Yes, which one of this will form only the normal oxide? normal oxide. Normal oxides means monooxides when it is reacted with air. Yes, it is C, right? Lithium. Only lithium forms the monoxide, while the others it forms peroxides and superoxides. Next, sodium carbonate is manufactured by Solvay's process. The products that are recycled are okay. So the products which are recycled by Solvay's is CO2 and NH3. Okay, carbon dioxide and ammonia. So the when you are manufacturing your sodium carbonate from by Solvay's process, the products which are recycled. Recycled means what? Reused are carbon dioxide and ammonia. So remember this. A is the option. When washing soda is heated, okay, when you wash, when you are washing, what is the washing soda is what?
Sodium carbonate.
Yes, Na2CO3.7 water molecule. Okay, so when this sodium carbonate, okay, sodium carbonate, it is heated. Okay, when you heat it, what it will lose? It will lose water molecule. So it will be associated with one water molecule. Okay, and you lose 6 water molecules. So what is a what is released, or water vapor is released. So when washing soda is heated, water vapor is released. So D is the correct option. Next, which of the following is incorrect? Okay, which of the following is incorrect? In the Casnell process of sodium extraction, NaCl is used as an electrolyte. B, sodium reduces CO2 to carbon. C, magnesium reacts with cold water and liberates hydrogen. This is also correct. Magnesium is an alloy of magnesium and zinc. The correct answer is B. Okay, so which of the correct, this is, so it is sodium. Okay, sodium reduces, so metals are good reducing agents. Okay, so sodium, when it reacts with carbon dioxide, so what it does, it reduces. So it Na2CO3 plus C. So it reduces carbon dioxide to carbon. So it is B. Okay, remember. The chemical composition of carnallite is, okay, so the chemical composition is KCl. Okay, this is the first one. A, KCl magnesium chloride dot 6 water molecules. So it is a soft white halide mineral. Okay, it is a soft white halide mineral which is hydrated potassium chloride and magnesium chloride. Okay, so which is having this particular formula. So the chemical composition of carnallite is potassium chloride dot magnesium chloride dot 6H2O. So this is the formula, chemical composition. Barium sulfate is water insoluble, although it is ionic compound, because of, what is the reason? The reason is C. Okay, lattice energy is more than your solvation energy. So barium sulfate is water insoluble. What is the reason? Because although it is ionic in nature, but the lattice energy, okay, lattice energy is more as than compared to the solvation energy. Among the following, okay, among the following, sodium hydroxide, calcium hydroxide, potassium hydroxide, and zinc hydroxide, the strongest base is, which is the strongest base? The strongest base is potassium hydroxide. Okay, C is the answer. Why? Because of the larger size. Because of the larger size of potassium, it can easily release the OH. So this hydroxide ions can be easily released. So KOH is a stronger base. Okay. So because of the larger size of potassium, it can easily release this hydroxide ions. So it is a stronger base. Alloys of dash metal are light and strong and hence used in manufacture of aeroplane parts. Okay. So the answer is Mg. Okay. The answer is D. So alloys of magnesium are used in manufacture of aeroplane parts. Gypsum is, what is gypsum? It is B. Okay, it is a soft sulfate material composed of calcium sulfate dihydride. Okay, it is B. It is B. So it is a soft sulfate material which is composed of calcium sulfate dihydride. Okay, so the correct answer is B. Next, gypsum calcium sulfate dot dihydride on heating to about 120 degrees Celsius forms plaster of Paris, which has chemical composition represented by. Yes, what is the chemical composition of this? It is 2 calcium sulfate, okay, 2 moles of calcium sulfate dot water molecule. Okay, so it is C. It is C. So 2 calcium sulfate dot 4 water molecule. It gives you what? It gives you 2 calcium sulfate dot water molecule. Okay. So this is the answer. Plaster of Paris is. Yes, what is plaster of Paris? What is plaster of Paris? It is C, right? Hemihydride. Calcium sulfate hemihydride. Setting of cement is an example of. Settling of cement is an example of exothermic reaction. Okay. So when water is added to cement, what will happen? And it is allowed to settle, right? So the reaction will occur. It will occur as an exothermic. That is what do you mean by exothermic? It generates heat. Okay. So when water is added to the cement and it is allowed to settle, that is what there will be emission, or there will be generating of heat. So it is exothermic. Exothermic means what? It will generate heat. So A, exothermic reaction. Which of the following is not a drying and dehydrating agent? Dehydrating agent. Yes, silica gel P2O5, then concentrated H2SO4, or hydrated calcium chloride. So which one of the following is not a drying and dehydrating agent? It is dehydrated, right? Hydrated calcium. You have to take work if you want to use. If you want to use as a dehydrating agent, it should be anhydrous, right? It should be anhydrous calcium chloride, not hydrated. It should be anhydrous. Then only it can observe your water molecules, right? Not hydrated. It is anhydrous calcium chloride. Next, mortar is a mixture of slate, lime, and sand in the ratio of it is 1:3. Remember this, the mortar. Okay, it is a mixture of slate, lime, and sand. The ratio is 1:3. It is 1:3. Which of the following are found in biological fluids? What is found in biological fluids? A, Na plus, Mg+2, Ca+2, and Sr+2. B, Na2 plus and K plus, C, Na plus, K plus, Mg+2 and Ca+2. D, Sr plus, Li and Ba+2. What is the correct option? What is formed in biological fluids? It is C. C is the correct option. Okay, C is the correct option. So it is found in the biological fluids. The element which on burning in air gives peroxide is, yes, which forms peroxides? Which forms peroxides? It is B. It is B. Okay, it is B. Sodium forms peroxides. Alkaline earth metals are not found free in nature. Why? What is the reason? Because of their greater chemical reactivity. Okay, D is the reason, because of their chemical reactivity. The most electropositive amongst the alkaline earth metal is, yes, which is the most electropositive amongst the alkaline earth metals, which can easily give this? It is D. Yes, barium. Okay. The next, the first ionization element ionization energies of alkaline earth metals are higher than those of alkali metals. This is because of, what is the reason why the first ionization energy of alkaline earth metals are higher than those of the alkali metals? What is the reason? What is the reason? It is B. There is decrease in the nuclear charge of the alkaline earth metals. Okay. So baking powder consists of, what does baking powder contains? What does baking powder contains? Yes, correct. A, which is manufactured by electrolysis of fused NaCl. Which is manufactured by electrolysis of fused NaCl. It is A, NaOH, right? NaOH. So by this, we have completed S block elements. Okay. So thank you for answering. So we'll meet in the next class. Thank you, students.